Okay, I better read this because I can see this almost got cut off here on my screen. This says write log base 3, x to the second power, y to the fourth power, so that's a 2 and a 4, divided by 9 times z to the fifth power, as a sum or difference of logarithms. Express powers as factors. So this time I thought I would write out the full set of instructions. It just means we're going to split this up into a bunch of logarithms, and that we won't have any logarithm of a number raised to a power when we're done. Okay, so it's actually the total opposite of what we did in the last topic. And again, this is just an exercise to get you to learn these rules of logarithms. You need to work these so you get those rules down in your head. All right, well, I'm in base 3 log, and here I've got a product and a difference. And so when we multiply, we split that apart, we're going to adding these logarithms and subtracting these logarithms. So we end up with log base 3 of x squared plus log base 3 y to the fourth, then minus log 9 base 3 minus log of z to the fifth power. So I split up the multiplications and divisions into additions and subtractions. And since these are in the denominator, they both got subtracted. All right, well, now we use the power rule. 2 goes over to here, that 4 goes there, this 5 goes here. And then what about our log of 9 base 3? Well, that's just the number 2, isn't it? Because 2 to the second power, 3 to the second power is 9. And so let me just, if you don't quite see that, the log of 9 base 3 is the log of 3 squared base 3. And the power rule says that's going to be, get my eraser. Power rule says that equals to 2 log 3 base 3. There's that power rule. And by that earlier rule, we said that this was equal to 1. So that's 2 times 1, which is 2. So that's one way of looking at log 9 base 3. Equals to 2. All right, so now we're ready to finish the problem. This is going to be 2 log base 3 of x plus 4 log y base 3 minus 2 minus 5 log z base 3. I forgot to write my 3 there, so don't forget to write your log bases. That's a little bit of detail that you got to keep track of. So, all right, there we go. It's all split up. I'll erase the board and we'll do one more of these. Same instructions, different problem. Write the log of the cube root, that's the third root, of this quantity, 2x squared over y z to the fourth. And notice this is a common log, it's a base 10 log. So I won't have to write a base this time because it is base 10. Okay, well, first of all, it's useful to change radicals into rational exponents, fractional exponents. So the cube root or third root is 1/3 power. So this would be the log of 2x squared y z to the fourth to the 1/3 power. And now let's take the power rule, multiply the 1/3 over here. So it ends up being 1/3 and of this logarithm. In fact, I'm going to write it over here just to save a little room. 1/3 log of 2x squared over yz to the fourth. Okay. And now I'm going to split up this logarithm. So it's 1/3 bracket log 2 plus 2 log x minus log y minus 4 log z. So here I skipped a step. The You know, these are added because they're multiplied on the top. These two terms are subtracted because they're dividing. And notice that I took the log of x squared is going to be 2 log x. I used the power rule with that 2 because x squared, 2 came over. Same with z to the 4th. It was z to the 4th would be 4 log z. All right, and express powers as factors. Oh, I believe I have. So we could distribute the 1 through 3rd through there. I don't think it's productive. So I'm going to leave the answer that way. So there we go. That's you should do all those in the textbook. Just that's how you learn the rules of logarithms, just by doing those practice problems. All right, we're going to go on to I think an interesting problem where we're going to estimate a number that's too big for your calculator to calculate.